Bueno, la primera presentación va a estar a cargo de Eun Choi. Ella es profesora asociada a la Universidad de Maryland College Park. Ella estudia el diseño y desarrollo de tecnologías para dar soporte a la mayoría de las interacciones entre individuos y sus datos personales. Utiliza diferentes métodos de investigación y diseño para evaluar las necesidades, objetivos y valores de los usuarios con respecto a su interacción con los datos personales. Realizó su doctorado en Ciencias de la Información en la Universidad de Washington, una maestría en Gestión y Sistemas de Información en la Universidad de California y su licenciatura en Diseño Industrial en Corea. So, hi Em, it's a pleasure having you today. I did your presentation in Spanish, so when you're ready, you can start.
Okay, thank you. Well, hello everyone. Thank you so much for inviting me to this talk. My name is Seung Choi, and today I will be talking about my research on ubiquitous data collection. I am a human-computer interaction researcher interested in using personal data to empower individuals. I design data collection tools, and I also design visualization and feedback to help people gain insights about their own personal data. And I do this work in the context of improving people's health and well-being. So consider different kinds of personal data, such as like step count, hour activity, but also other types of data that we don't normally think about. So for example, how much we are sitting, how much we are standing, how much we are productive, how much time we spend in front of computer or using smartphone. So I'm interested in all these different kinds of personal data, and I think about ways to collect them and then show feedback and visualization. I want to start today's talk by talking about my colleague, Alex, who is a health researcher, and he is aiming to understand what factors aggravate paranoia patient symptoms by collecting in situ data, such as location data or social interaction data and activity data. Also, suppose you have IBS or irritable bowel syndrome, and the doctor does not know what triggers this condition. And in fact, the doctor asks the patient to collect data, like the food data or the symptoms, so that the doctor and the patient can get the data together to make sense of the data to identify the triggers and more specific treatment options. So this is an example of self-tracking. While these two stories are quite different, they share many commonalities and data collection challenges. And how to support personal data tracking in these two different contexts, either to support the researchers or either to support individuals or patients, is the subject of my research. The area of my research is called personal informatics, and I want to start by talking about the really high-level overview of personal informatics. Personal informatics, or the collection of personal data, is not new. In fact, lay individuals have been collecting their own data for a long time. More than 100 years ago, this coin-operated public vending machine called the penny scale enabled the general public to watch their weight without going to the doctor's office. And nowadays, many people track different kinds of data using their own devices that are mobile, wearable, or embedded. And moreover, researchers are tapping into the data collected by these commercial devices. However, these commercial devices are often not flexible and not inclusive enough to meet people's diverse needs. For example, when iOS Health first came out, they did not support one of the most common things that people track, which is the menstrual cycle. And when this happens, people were bounded by how the tool was initially designed, and they could not modify or add a tracking element, and they ended up quit tracking entirely. Data access is another problem with consumer health apps. Even when you contributed in collecting your own data, about 10% of personal health apps do not provide any means to access your data. And in general, there are three different methods to access your data. The first method is to synchronize the data with other health platforms, such as Apple Health, and you can get the data through those platforms, but the kind of data that you can get are quite limited. The second method is the file download. Some apps do provide direct access to their the raw data, and they provide the file download. And then the last way is using API or application programming interface. We found that trade-offs exist across the three different access methods regarding the required skills and granularity of the accessible data. So the more fine-grained data people want to access, the more advanced skills they need to have. So APIs provide finer-grained data, but are difficult to use by general public. And health platform and file downloads are easier to lay individuals, but they typically put a significant limit on data format, granularity, and data amount. So these limitations constrain people from easily repurposing the data. So my approach to address some of these challenges is to facilitate personalized tracking experience. And as a first step, we enabled people to construct their own trackers composed of different building blocks of data for different people, just like what you see in this image. To create flexible trackers that support personalized tracking experience, we first propose a concept of semi-automated tracking. So semi-automated tracking combines both manual and automated ways to collect data. When you think about different ways of collecting data, you can think of this as a spectrum. On one end, there's the fully manual tracking, such as using pen and paper or write things down on a notebook or using Excel spreadsheet to type your data. On the other end of extreme, there's a fully automated tracking. So for example, using wearables or the data are being collected automatically in the back end. They have different advantages and disadvantages. So for example, with a fully automated tracking method, it definitely lowers the capture burden because data are being automatically collected, and sometimes it's more accurate, like the case of step count. However, you have to remember to wear these devices or carry the devices all the time. And more importantly, it reduces engagement with the data. When it comes to fully manual tracking, it's definitely more flexible. And because people are engaging in the data collection themselves, it increases their self-awareness. And some data, like subjective sleep quality, can only be tracked manually by definition. But as all of you know, it imposes high capture burden, and people tend to forget the recording, and it compromises the data accuracy. So what we are proposing is to combine the best of both worlds. So we propose semi-automated tracking where the data is collected by both a person and a system. And it can be more accurate than fully manual or fully automated, because when system is more accurate in collecting data, we combine the system. And when people are more accurately collecting data, then we engage people. It also maintains awareness and engagement of the users. So these are some of the benefits of semi-automated tracking. To create flexible tracker through semi-automated tracking, we proposed this system called OmniTrack. So OmniTrack combines both manual and automated ways of tracking data. And when it comes to the manual tracking, we supported people to add these different kinds of manual fields, such as short text, long text, numbers, rating, time, and other things that are commonly appear in many of the manual tracking tools. When it comes to automated tracking, we supported different kind of wearable systems that support APIs so that we can pull in data from these commercially available sensors and systems. So using OmniTrack, you can combine these manual fields with automated sensing data fields and then create your own trackers based on your own needs. And people can build custom trackers without programming on their mobile phone. So let me show you an example of a sleep tracker, how you might create a sleep tracker using OmniTrack. So in a sleep tracker, I want to include this kind of different fields. I am a heavy coffee drinker, and I know that it affects my sleep. So I want to track how much caffeine I intake. I also want to capture different activities before sleep, whether I watch TV or I work or I take shower or doing yoga, that kind of stuff. And of course, I needed to track sleep duration when I went to bed and when I wake up, and the subjective quality of sleep. All of these data can be tracked all manually using the manual field. However, one of these, which is sleep duration, can be automatically collected from Fitbit. So now we are adding a little bit of automation in the tracker. So we can use the Fitbit API to pull in the sleep duration data. We can automate this even further by setting something called trigger, which is something like a timer. So at 12 a.m., I set the trigger so that the Fitbit data is automatically synced at that time. So people don't have to do anything at that time. So as you can see, you can slowly increase the level of automation for that particular field. Currently, OmniTrack also supports simple visualizations on the dashboard page, depending on a few heuristics. So for example, if people are tracking categorical data, we automatically create a bar chart. If people are tracking time series data, then we can visualize the data using line chart. And if people are tracking duration, then we can create duration charts and etc. And with OmniTrack, people can create a variety of trackers. And in a field deployment study, here are some of different trackers that people created. So for example, breakfast tracker versus meal tracker, travel log, and other things. Let's see. Now, I want to talk about an application domain where a system like OmniTrack can be used to support personalized tracking experience. So we specifically worked with dietitians, and we conducted a co-design study to create food trackers with dietitians to identify opportunities for food tracking customization. In a clinical context, clinicians can use our tool to create a custom tracker for each patient, especially with dietitians. They see different types of patients with food-related disorders. So for example, people with irritable bowel syndrome, or people with obesity problems, or people with eating disorder problems. Depending on what kind of disease people have, their tracking needs are quite different. Although many people just use pen and paper to track food, but when we actually studied the actual tracking needs, their needs are quite different. So in this particular study, we wanted to understand how to support food tracker customizations, and more specifically, how do dietitians customize a food tracker for their patients. To answer these research questions, we conducted a co-design session with 6 registered dietitians who see different types of patients with different dietary issues. So WM refers to weight management, ED refers to eating disorder, and diabetes and GI is gastrointestinal distress. So these 6 dietitians have a varying level of years of experience, and they work in all different environments, and they see different types of patients. We first asked them to create 2 patient personas based on the representative patient types that they see, and asked to create a food tracker for the 2 personas that they created. So I'm first going to show you some examples of the patient persona. So the first patient persona that P2 participant 2 created was an eating disorder patient who has anorexia nervosa, a particular type of eating disorder. And these patients have issues with over-restricting diet and over-exercising. And the patient's goal is to increase calorie intake and increase food variety. Another participant created eating disorder patient that is different from the first one. This particular patient has bulimia nervosa, which is a very different type of eating disorder. And this particular patient also has prediabetes. And lastly, these are just 3 out of 6 different, 12 patient personas. And the last one has weight management problem. And then we asked dietitians to customize the food tracker for these different types of personas. So I will first show you one food tracker customization for the first eating disorder patient. As you can see, this registered dietitian included a lot of different kinds of data that are relevant for this particular patient, including the meal, the food items, and other things. But you will notice that this is very different from a typical food tracker or food diary that asks people to track things like very detailed meal ingredients and calories. In fact, for eating disorder patients, it is much more important to support their reflection on the food and their self-care behaviors and coping skills whenever they have eating disorder symptoms. So for example, you will see this kind of self-care behaviors, the kind of activities that people did to honor their body, and then things the patient feel proud of, what they think about the body image and challenge food, whether they were able to try challenge food and other eating disorder behaviors. So those are different kind of symptoms. So these are the kind of things that the dietitians wanted this eating disorder patient to track instead of a typical calorie or ingredient-based food diary. During the study, we found that the tracker design is a product of these 2 different things. First, the patient tracking needs, depending on whether they have eating disorder or weight management issues, but also the provider's practice style. Providers' practice style quite varied broadly, and based on their style, they also designed the tracker in different ways. So in going forward, we see an opportunity to support dietitians in creating tracking templates, which can be shared with other providers. And they can also modify or add the templates so that they don't have to create food trackers from scratch. We also see opportunities to leverage OmniTrack in creating these customizable trackers. And going beyond these traditional mobile and wearable devices, we are now examining speech as a new input modality to capture data. So smart speakers operated by speech is promising in helping people capture data in a more flexible and natural way. However, smart speakers' main drawback is its lack of visual elements. So instead of comparing and competing these 2 different modalities, we are trying to combine these 2 modalities. So we are using speech as an additional modality that complements this mobile and wearable devices. And I believe that speech should be particularly useful when people are occupied, for example, when they are exercising, when they're eating or driving. In the same vein, we have recently embarked on a project designing multimodal data tracking system leveraging speech and touch interactions on a variety of devices. And we will collect personal data to build personalized models to design more inclusive self-tracking systems for older adults. User-generated labels are expensive and hard to collect in people's own environment, especially from marginalized groups such as older adults. In this particular project, we are hoping to create a self-tracking systems that can benefit both the researchers and the end users. The researchers will use the user-generated labels to build personalized and more accurate models, while older adults will be engaging in the data collection as part of the self-tracking their own behavior. So in this talk, I talked about various ways to collect this in situ personal health data. And to collect high quality data, I argue that you first have to start from what individual schools are, either those who are contributing and tracking data or those who are doing research or even the clinicians. So start from designing a data collection tool that best suits people's goal. And then I also argue that you have to leverage multimodal tracking to reduce capture burden. So for example, think about different ways of combining different modalities such as speech and touch, or incorporating wearables, or leveraging the semi-automated tracking methods. And lastly, we should think about ways to provide values for those who contribute in data collection, whether that being the benefits induced by self-tracking or easier data access. And through these measures, I do hope to empower both researchers and individuals. So with that, I will conclude my talk, and these are my collaborators at University of Maryland and other places. Thank you.
Thank you for your presentation, Eun. There are some questions. One of them is, people track too much and they get burned out really quickly. Does any way to help people to avoid that?
So it's true that self-tracking requires a lot of effort, and that's why we want to leverage both the manual and automated ways to track data. So for example, when people are tracking data initially, you have to think about different motivations. Do they have high motivation? Do they have low motivation? Let's say they are motivated but as they engage in the tracking and as they collect more data, then some people see the benefits of doing it. So for example, through looking at the feedback, or as they engage in the data collection practice, their awareness goes up and they are engaging more. And in some cases that induces behavior change or change of a certain behavior's frequency. And as they engage more, then their motivation becomes higher and higher. And then that's when you can think about incorporating other types of tracking that requires manual. But initially, depending on people's motivation level, you have to think about how much of a data capture burden to impose and what kind of benefits you can provide back to people.
Okay, thank you. Well, the next question is, do you think there should be some kind of government incentive to promote the use of these technologies?
Incentives comes in a lot of different ways. And I didn't talk more in detail about the two particular purposes of self-tracking. One is purely for assessment. So assessing, so for example, clinicians assessing the patient's state. And in that particular case, there's not much benefits or rewards for the patients. They're just collecting data and then providing the data back to the clinician. But maybe the benefit is this their expectation to receive better treatment, or expectations to get more accurate diagnosis. But sometimes self-tracking tools are designed for the purpose of therapeutic. So the self-tracking itself is a therapeutic activities, and it's part of the treatment, as in the case of cognitive behavior therapy. So in that case, as people are engaging in the data collection, as people are doing self-tracking, that's part of the therapy. And if they are doing it correctly, and if the CBT is the right way for a particular patient, I believe that the patient will experience the benefits itself. So for example, CBT for, let's say, insomnia, that's for treating their insomnia symptoms. If they engage it, and if it's the right method, then patients will get better. So that itself can be, I think, a huge benefits.
Okay, the last question is, which do you think are the biggest challenge for a widespread adoption of wearables in the community?
That's a really loaded question, but I will point you to this particular case. A lot of wearables are actually designed for younger people, those who can purchase them, which those who can afford those devices. But chances are they are not the group who will get benefit from those commercial devices. It's usually the patients, usually the older adults. They are the ones who will really get benefit through self-tracking and use of wearable tech. But a lot of studies show that they are not the least adopting these devices for a lot of reasons. So I think as a researcher working in this field, I think we have to think about what are the ways to motivate this marginalized population, such as older adults and people with different kind of disability, to get benefits from wearables.